So it's only for those of you that didn't do it yet, okay? And then I haven't, for those of you who already did it, I haven't graded yet. Okay. So even though the exam I give you a specific grade, this is not a grade yet because I need to go and look it up. All the essay part or the short answer one, I need to go and look it up myself. And then I'm gonna upgrade your grades by next week. Okay. I shall finish it this week, but because there are so many people saying that they have the chance to do it. Okay. So I extend it until this Friday. Okay. Hopefully, I hope that helps. So last week, I mean not last week, like on Tuesday, we were doing something called whenever looking for the mean and also something called the standard error. And then these are the formula we use for it. And then just remind the formula quickly there. Let's go that way. It's right here for proportion. And you got the mean P or mu P hat, and then the sigma P hat. All right. And then for the sigma P hat, you use that specific formula to get it, the square of P, 1 minus P divided by N. Or you can use P hat minus P hat parentheses 1 minus P hat divided by N. We did say that before. Okay, we're gonna continue the class. We have other examples available, like this one right here. I'm gonna skip it. I'm gonna leave this one for you to just read it do on your own whenever I send you the notes. Okay, so you see how it look like. You find the standard error, you've got the mean, you got the standard error. Okay, and then the sample distribution will be 0.78 and then 0.017. But that's something I want to point out to you. Not only that, I want you to read that, but something I want to point out too. This is this one here. This one say, yeah, I need to work this. I'm gonna work this one, but I will not find with you the mean and the standard error. Okay. Like for example, you say that here's to say 70% of all laboratory mass can make it through a maze. If 600 randomly selected mass are selected, okay? 600 selected mice attend the maze. What is the probability that more than 80% of them will make it through the maze? The first thing we're going to be doing, whether we can use the formula we have earlier by doing this thing that called NP. So that we did the NP and N 1 minus P. Once you do them, if it's more than 10, then it's okay. As you can see, in both of them, they are more than 10. Okay, so the population is large. Okay, so you can think about all mass in existence. By the way, we got 600, which is a large population. Also, if you have something like this as well, then that is more than 10. Okay, all right. So besides 468 plus 132, it does give you 600 as well. Okay, just on this side. Give me one moment. Still coming here. Anybody? All right, then. So we already know how to get that. Now, the next thing to do in this problem is this is what they say. They say, what is the probability that more than 80% of them will make it through the maze? So you want to do that. So what we're going to be doing is going to be probability of something. Okay. Some X. Let's put it a little, what is that can we use? Okay, some number ESP plus 80%. Okay. Okay. So I want to know what will it be? The probability of plus 80%. Now, the first thing we're going to be doing is do the following thing. We need to be able to get the Z-score, the Z for it. Okay. If we get the Z, then it'll be easier for us with the problem. Remember, the Z say something like this, something like this, which is going to be the the x minus x bar, the one that we learned before, is going to be the mean, the x minus x, let's put mu, over sigma. Okay, that's the formula that we learned. But because it's in proportion, this will be something like this in this case. That will be p hat minus mu, okay, p hat minus up, something like this, over sigma p hat, okay, and so on. So it's kind of the same formula I've been using before, which is the x minus the mean variance. You can use the same thing that I just translated into the proportion part. Okay, so let's keep walking. Let's see. So this is what we have. Using the Charlie mean theorem, we have the mean as 0.78, just like we have earlier here. This is the mean because it's of all laboratory. This is P. Okay, or you can say this one is mu P hat. Okay, that's gonna be the mean. All right. Okay, and then the standard error. Just like we said, the formula, the standard which is gonna be, this one is, I'll just erase that part here. Again, the mean is what you call the mu P hat, because it's talking about a proportion. And the standard error will be sigma P hat. Okay, so they select 600. So they say if they want to be, what's probably that would be more than 80%. Okay, that one here, we don't that consider as P hat. So I'm going to show it to you now. So in that case, for now, the simple distribution would be, this is the mean P hat, just like we did before, and this is the standard error, sigma P hat. Okay, that's what we have so far. This is what we've been doing last class. Okay, so I'll do introduce the 80% now. This is what I'm going to be doing. So if you're using a stat crunch, I'm sorry, stat disk or stat crunch, whatever it is. Okay, so this is what we have. Okay, so you're gonna put it in the calculator, and then we already teach you last time how to use stat crunch. I already did that with you. So here in that case, you're gonna put the mean, and the latest step here you're gonna put the mean. This is mu px p hat, and this one will be sigma p hat. And over there, you're gonna put P, right? If you were to do it by hand, this is what we have. That'd be Z, okay? No, that'll be Z is equal to P minus P hat. I'm sorry, P hat minus P over the standard error, okay? Which is just gonna be the square root of P 1 minus P over N. Okay, so this is to get this number, but with stat crunch, you don't have to do that much thing. You just put the number inside, and then you're able to get probability of let's put X greater, because you say more than 0.8 is equal to 0.1197. Okay, so this is using The same system we are using last time. Do you guys remember how to use that system? And I think apparently I did say that you can use it also in the exam, okay? Or you can use the one from the TR-84, okay? Does anybody remember how to get that? I mean, does everybody remember how to get that? Okay, so if you remember how to get that, so I'm not gonna go over it right now. So that's mean the probability that 600 of them will be, more than 80% of them will make it through the maze. That'll be about 12%. That's what you can say. You can say all 12%. If you're gonna want it's gonna be 12%, will be able to make it, okay? So this is what we say, oopsie, sorry. So about 12% will be able to do it. So now, one of the time we're gonna be able to use the central limit theorem, which we talked earlier about, if your number is less than 10, okay? Like for example, in this case, you have a large sample size, and then you're taking at least 1% of them, but that number give you 5, which is less than 10. Remember that magic number 10, we don't want to be less than 10. If you said the then, so that's a big no-no, you cannot use the formula, okay? And then you also apply for n, 1 minus p as well. If it's less than 10, I mean, both of them need to be greater than 10, okay? So if one of them doesn't happen, then that's a problem, okay? And also when people say, oh, the other one is greater than 10, but even though both of the results must be greater at the same time, okay? Now, if you don't have that, if you have less than 10, anything that is less than 10, if you use a formula, if it's less than 10, then you cannot apply the central limit theorem. Sorry about them, just erase that. Okay, so that's something that we need to remember when taking the exam. Okay, so this one, do not use the normal distribution to calculate this probability. We do have other way to do it, which we're not going to be teaching in that specific class. And this is called a non-parametric statistics, but it is not part of your class right now. And in our case, we won't be able to do it. It's just going to be satisfied with that. Okay. Now, the thing I'm going to talk to you about is something called. By the way, does anybody have any question? No questions. And again, try to remember whenever you use StatCrunch, how to input the mean, the standard deviation, and the X value. Remember that, okay? We did that many times in class, and as examples, in multiple examples, we did like that. Now, what I want to introduce to you something called confidence interval. This is going to be based on what we just learned. Again, we learn about the mean. Let me just go back right here. Again, we learn about something called the mean. Okay, let's do it for proportion this time. We're talking about proportion. Wow. Let's see. Let's talk about proportion. While talking about proportion, so we're gonna have something called mu p hat and sigma p hat. Okay, and then this is gonna be assumed to be normal. Whenever what I mean by normal, it means that they're gonna have that bear shape that we were talking before. And then what we have is gonna be the following thing here. So suppose we're talking about the population now. The population has a proportion P, okay? Then what you're gonna be doing, you're gonna take a sample. Your sample can be any sample, okay? So this will generate a p hat. Okay, this is the problem. The problem is that the p hat can be off. Okay, it can be off. It can be plus or minus some error to get you to the p. It means at the same time, you can have p hat, okay, minus e as an interval, and then p hat plus e, and then p can be empty. Let me do a line for you instead. Suppose you have the line right here. Okay, suppose you have a table, a line. This is going to be p hat minus e, some error. Okay, this is the error. Which we can call also margin of error. Margin of error. Okay, so I did say that earlier. Whatever the sample you took, it can happen that that sample, I can select a sample, then the mean can be there, it cannot be there, or I can overestimate, I can underestimate. It can happen, but for sure this will happen. You're gonna have some error, and then this can be also p hat plus e. So this is how the quiz that can happen. It can happen that p fall here. Wow. P can fall inside here. Then I did a good thing. Okay. P can fall inside here. Okay, then that's okay. You know, also, other thing that can happen, also P can also fall outside. If P fall right here, then I can say that I overestimate, I underestimate. Okay, now I'm sorry, I overestimate. Okay, because my p hat is in that range right here. Okay, this is how I say p. So whenever there'll be an error, okay, that might be off by some error. Okay, that'd be that. And then if the p fall over there, if the p fall over there, then that means I underestimate. Okay, because my value is p. Okay, because the p is below it. All right. So whenever you do it, there'll be some error, which is gonna be between the error will be e. Okay. Another way to write it down, so I can say with some confidence, with some confidence. Wow, hold on. You can say that, let's see, let's put with some level of confidence. That means this I'll show you about something, okay? With some level of confidence. You can say that you're gonna have p hat. I need to see how this to stop doing that and doing to me and on keep having that line going up all the time. Give me a moment. I'm just taking my pen. Yeah, that'd be p hat minus e less than p hat plus e. You can also say that. Okay, so there'll be an interval. The p will belong to some interval, something like that. And this one is a, and this one is b, something like this. Then this is a. Okay, and this one is b. Okay. So I'm gonna do a couple examples, something with you, so you probably can try to get what I'm talking about. so you can get an idea. But this is something we have to understand as well. The E, whenever you have the E, whenever you have the error, the margin of error, suppose you got the margin of error E, okay, is dependent of some value. Okay, so you can say, I'm going to give a formula that goes with it. So if you have P hat, okay, then you got an E, which is the margin of error. This is going to be the sample proportion. That can give you something like X. Some people like to say X over N if you want to. We talked about it before. Something like X over N. Okay. While the E itself is going to be some constant value that will be generated based on the confidence interval. Based on your confidence, there'll be some constant value I'm going to be using. Okay, for now, I'm going to call it Z. Okay, that Z value, you're going to multiply it by the standard error. This Z value is dependent on the level of confidence. Okay, I will be talking about it. What do you mean by level of confidence soon? But just like a little bit, okay? So everybody's be confused. On some level of confidence. Yes, level of confidence. Okay? Sometimes it will be given to you. Sometimes it won't be given to you. Okay, sometimes you're gonna have to calculate it. And the good thing about it, if you're using StatCrunch, yeah, so StatCrunch, you don't have to really worry about it too much, but if you have to know the level of confidence. So the level of confidence must be given to you. If not, by default, it'll be 95%. Okay, so level of confidence. Okay, let's talk about that. I'll talk about it again soon. Now, this is what happened. Again, a confidence interval for population bias is an interval where the unknown population proportion is likely to lie. That's why I said earlier. So we have some interval, something like that. This is P hat minus E. This is P hat plus E. Then P is inside that interval. Is likely to lie. That's what I mean. The P I'm confident that P is inside that interval. It doesn't mean I'm 100%. Remember that we cannot be 100% sure. When I say 100%, that's my level of confidence. I can be 95% sure. I can be 75% sure about it. This is why it lie. It lie in that interval. Okay. So assuming the population proportion is unknown. In that case. So is this an example? Here they give you, suppose the central limit theorem applies to one wants to estimate P. You would have to find P. They give you P hat, which is the sample proportion, and also they give you a standard error. All right. So this is what's gonna happen. So I'm gonna be doing this thing right here. This is they give you 1.96 right here. Okay. That's the Z time the standard error. I'll give it to you this time. Sometime I can just give it. I will show you later on today when I give it to you which number to use. For the 1.96, it means that you are 95% confident. Then you're gonna find that you are 95% confident about it. That's the 1.96 come from. If there's, I will show you the relationship later on today. That's me. If I use the number 1.96, it means that I'm 95% confident, but that my P will be in that specific interval. Let's find each interval. The first one say p hat minus that, okay? That's the first one. As you can see here, we have p hat right here, minus the z times the standard error, okay? And then after that, we're gonna do the same thing as well. It's gonna be p plus the z times the standard error. So this give you two values, okay? Give you an interval. I can say this is 0.19, and then this is 0.30. So that's mean I am 95% confident that P is in that interval. That means if someone go and look for it, 95% of the time, that number will be in that range. Okay? 95% of the time, that number will be in that range. That's what it means. So again, they say you can be 95% confident that the population proportion is between 0.19 and 0.30. Okay? Again, 1.96 is associated with 95%. I'll show you about something. Again, the 95%, don't take it wrong. Suppose you have a hand sanitizer, okay? So your hand sanitizer can be 99% it kill germs, or 95% it kill germs. So that's very important. If you're gonna say, if I buy hand sanitizer and it say it kills 60% of the germs, I will not go and buy it. I will go and buy the one that say 99.9%, 99.9%, kill 99.9% of germs. This is how confident we are that we're gonna be able to kill the germs. So I want to pay attention to that. This is how confident we are we're gonna be able to kill the germs. If it's a 99.9%, that's the idea behind the 95%. Is I'll show you what. This is a good estimate. This is a good idea to see how confident you're about something. In statistics, you don't want to say 100%, because if there's an error, then you can get sued. Okay, and that's what happens if you have a medication that you come out and put into the world. You don't want to say 100%. Okay, because something happened, then you're gonna get sued. You can say 99.9%, and somebody say, hey, that thing did something to me, so I'm gonna sue. You can say, remember that I say probably 99% is gonna kill this 1%. There'll be an error. Then that person remember that, say, oh, there was a 1% margin, so then I should be fine. Okay, so and then you're not gonna be sued, something like that. Okay, that's the idea behind that. Does anybody have any questions before I continue? Any questions? Okay. Now, let's give an idea. Sometime, just like I don't know if you remember the example we did earlier about the 5 people, and then you're gonna say three, assuming these 5 people are just the entire population, you're gonna say 3 people. And sometimes the mean can be inside and not inside. Based on that example, we're gonna do something like this. Suppose they say, this is for population. Suppose they give the population as P, which is equal to 0.96, 0.16, for example, like that. Let me use a different color. P, this is for population, okay? Why is it the same color still? I need the red one. You got P, for example, is equal to 0.60. I know this is given to you, okay? But we're gonna do something. Assuming it is unknown. Let's see what happened. Assuming this one was unknown, 0.16. Okay. So assuming this one was unknown, we then know 0.16 on this side. Then we're gonna find the 95% confidence interval. I mean, that means whenever you say 95% confidence, that means the Z is 1.96. Okay. You're gonna multiply by that number by the standard error. Okay, I'm not gonna show the steps, and it's very easy for you. Suppose I do something like this. I find all the intervals. I use different samples. So that this can be done in Snap Punch. Okay, as you can see here, 0.16 is there. 0.16 is there. It's kind of like in the middle. We got 0.16 right here, kind of closer to 0.17. Got 0.16 over there as well, kind of closer to 0.15. And also here, 0.16 is off the chart. Okay. And in that case, probably I underestimate if it's off the chart. And also here, you got 0.16 closer to 0.17, etc. These are different intervals that you can generate. All right. So, and so on. And also, if you want, I can also add one in which it is more than that. I can say, for example, 0.17 and then 0.19, 0.20. In this case, the 0.16 is below. In that case, I overestimate. Okay, so each one of them are just p hat minus the error, margin of error, and then p hat plus the margin of error. Okay, each one of them, but it's even of the sample that I chose. All right. So based on what we have here, only everything as the mean except this one. In that case, because I told one of the examples, I can just say except when 11.15. I can also I can just add this one. I can say also 0.17 and then 0.20. They don't have the population proportion. Okay, that was a broad idea of why we need the confidence interval. That's mean though all confidence interval will be the same based on the sample that you're choosing. This is what's going to define it. Okay, all right. This is if you are doing if you're doing a study by yourself. If I ask you to do a research, then that's going to happen. Whenever you're taking the exam, most of the example will be like just straightforward. Okay, you're not going to have too many things to do like this. But this is if you are doing some research, and I'll go ask you to find 30 people out of the school, and somebody else go out look for 30 people out of the school. Your result will be similar, okay, but you may have different intervals. All right, that's what I just want to point out. And then so this one say for every random sample that can be taken from a population, there corresponds on 95% of the interval. So 95% of this interval will successfully contain the population proportion, and 5% will not. So whenever you do your research, you can have been that 95% of the time. If you use 95% of confidence level, it's gonna be fine, and 5% it will not. Okay, that's the idea behind 95%. We do also have other expressions, so now we use 99%, something like that. But I can just show it to you quickly here. Hold on. Right here. Let's keep that for now. See that? We do have other ideas. We also use 99.99%. In that case, going to be using 2.58 times the standard error. If you see 95%, that means you have to use 1.96. If you see 90%, that's we're gonna be using 1.645. And then if you say 80%, it's gonna be 1.28. What I will do, if I were you, I write this number down in my cheat sheet. And also, whenever you're taking the exam, more of them will be given to you. So you don't have to try to do them. The one that you use the most is the 95%. This is the most common one. Okay, most of the time it's gonna be 95% because this is the most common, most acceptable one. Okay, 90% is fine. We use it. 80% is fine, but the most common one will be 95%. But If it's 99%, that you have to use 2.58 times the standard error. Okay. So notice that if you increase the level of confidence, increasing the level of confidence also increase the margin of error. That's why I say right here. Here we have a smaller margin of error. Here you have a bigger margin of error. Increasing the level of confidence also increase the margin of error. So use a sentence just in case something happened to you. So let's go back here quickly. Oh no, I'm not supposed to be doing that. Yeah. So here, this example say that kind of the same thing we were doing earlier. So we got 500 random people selected, 72 were smokers, find a 95% confidence interval. So what I do, I find the p-hat because it's 72 out of 500 people. It means 72 divided by 500. This is to get the population, this is to get the simple proportion. Then you did the standard error using the formula that we learned before. In this formula, we didn't know P. P was unknown because they didn't give it to you. If P was unknown, you can use P hat here. Here, we use P hat. We did say that before. If P is unknown, you're going to use P hat. Okay? Then you get standard error. So because they say 95% right here, so I'm going to have to use 1.96, just like we say in the equivalent example. And then you time that down to standard error and then do P hat minus E and P hat plus E. Then you get an interval, 0.113, and then 0.175. So what I'm going to say, I am 95% confident that P is between this interval. Okay, P is within an interval. Okay, I'm 95% confident about it. Okay, I can say I'm 95% confident that 11.3 and 17.5% of all people are smokers. You can also say that as well. Okay. So, any question about that idea? Okay, so there's no question. So we'll just talk about that one over here. We just remember that little thing. If it's a 99%, it's 2.58. If it's a 95%, it's 1.96. There's a way to find them. I can show you the video later on and like I can in StatCrunch, but you don't have to. But as you do the exam, you can just use them. Okay. So now I do have a question. Because nobody have any questions, so I do have a question for you as well. This is a thing for you to read. I will put the notes for available. The note will be available for you after class. Read those, and then this is important. Save that. Okay. So this one say 176 of 200 patients when I'm selected to receive treatment survive. Find the 90% confidence interval. So anybody can get me the p hat? Can you get me the p hat? What will be p hat? And what is the margin of error E? Again, p hat is X over N. And E will be the square root of P hat, P is not given, 1 minus P hat divided by N, okay? So we need to find these elements. So can somebody get me P hat and also E? Okay, so I'm waiting. I'm still waiting. If you don't know which one is X and N, look what we did before. Okay, so thank you, Marilu. So that's gonna give you 0.88. That is 0.88, thank you. So your X, like we said earlier, your X will be this one, and this is your N, just like we said earlier in the previous example, okay? So now we need to find the margin of error E. We would like to find the margin of error E. But what you need to do now is work on the review. The review have plenty of examples like this. If you don't see them in the homework, because the person is a third party, if you don't see them on the homework, you should be able to see them in the homework. But if you don't, you use the review sheet, do that over and over again. Okay, thank you very much. The next one will be, yes, that'll be 0.023. Now, this one say is 90% confident. So if you're 90% confident, we would like to know what number we can use to find the confidence interval. So we need to know which number you use. So based on what we learned earlier over here, let me just go back here. As you can see right there, if you say 90%, the number will be 1.645, okay? So this is a number that I must multiply with the standard error, okay, to get the margin of error. So let's go together, get the margin of error. Okay, so it's gonna be 1.645. So here, as you can see, this will give you the margin of error. I'll put ME, this is margin of error. This is the standard error. Okay, that's a S. And this is the Z. Okay, of 90%. We talked about Z before. Whenever we used to do that formula here, Z is equal to X minus mu over sigma. We talked about that Z before. Now this is for standard values. That value here, the Z is whenever you have Z such as, you're gonna have like some number minus the standard error and then 1. In this case, this is for normal distribution. So this is what happened. Each time they give you the confidence, if they give you 90%, you need to put 1.645 for Z. If they give you 95%, you should see 1.96. If they say 99%, you need to put 2.58. That's how we do it. If they say 80%, you need to put 1.28. And also I can show you how to find it, and I can show you, this is for standard normal. And also I can show you, just in case if you get stuck, how to find it and what do you got again? And StatCrunch. Let me just use StatCrunch for a minute so I can show you how to find in StatCrunch. Let me go to StatCrunch for a minute. Let me go to my Stat Lab and I'll come back to this one. Let's go to StatCrunch. One minute, okay, I'm just gonna go in right now. StatCrunch. Need to log in first. Moment, so I need to sign in first. Let's go StatCrunch website. And StatCrunch. See. Normal. I'm going to show it to you right now. Give me a moment. Okay, let me just share my screen with you. Okay, I have to stop sharing that for a minute. So stop sharing that. Let me just close that. Stop sharing. Let's share my screen just in case. I mean, you should be able to do it in the TI-84 very well. But because I'm not able to share the TI-84 with you, but whenever you do the review, the TI-84 you're gonna be able to see it in the TI-84. Okay, so let me share StatCrunch right here. Okay, now whenever I go to StatCrunch, you're gonna go to Stat Calculators, and you're gonna go to Normal. For you to do that, it's best to use the B3. Okay, whenever you have to wanna find the Z, it's best to use the B3 for now. Okay, because I'm using between because you got two sides. Okay, one left, one left, and one right side, because you're doing an interval. In an interval, you got two values. It's best to use the between. So the first thing I'm trying to do is to find the 99%. So I'm gonna go here and put 0.99. And I say compute. As you can see, give me 2.58. You see the 2.58? Can you share? Can you confirm that you guys see the 2.58 there? It can be negative 2.58 or positive 2.58, but I just need 2.58. That's all. Can you guys see it? Can you guys see the 2.58? Yes. So suppose I say 0.96, and I say compute. As you can see, not 0.96. I'm sorry. 0.95. I meant 0.95. If you do 0.95, as you can see, give you 1.96. See that? Negative or positive 1, because you got two sides. One is negative, the one was positive. Okay. Suppose I say 0.88 now. 88, and I say compute. You can see give you 1.55 and 1.5, just like we had earlier. I'm sorry, I say 80. And the paper has 80. You got 1.28 on both sides. One is negative, and the one is positive. Okay, so I'm going to sharing that right now. Yes, this one way. If you don't remember them, you can do it. Okay, so let me start sharing it right now. Share my screen. Where's my screen? Where's my screen? Right here. So this is one of the reasons we have two. I use the two-sided because you got two sides whenever you do a confidence interval. Whenever you do the interval, you got two type of values. Okay. As you can see here, we have one negative, and the reason why it's come from this guy because you got a plus and a negative 1.96. That's the reason we have a negative here, okay, and then a positive there. That's why I showed you earlier. That's why I did two sides. Okay. So then when I get my confidence interval, I got my value right here as 0.88842 and 0.9918. So I'm gonna say now, because I use 1.96 and 95%, 90%, I will say I am 90% confident that between 84.2% and 91.8% of all people who receive the treatment survive. Okay, so 84% and to 91% of all the people who receive the treatment survive. Or you can say P is between these two values. You can say P belongs to this interval. Okay, that's one way as well. Okay. So we do have other example that we can use. Okay, so let me see if I can do something else. Now let's see if I can, let me show you how to find a confidence interval online. Let's see, we just talked about this one, right? Here we saw that we have point something and 0.90. How do we get that using StatQuench? Suppose I wanted to use, I don't want to use my hand. So I say, I don't want to care about that 1.605 thing. So I would like just worry about the 0.90%. So how do I do that? Okay, so I'm gonna stop sharing that. I'm gonna show you how to do in StatQuench. Okay, you also can do it in the TI-84, which is given to you whenever you do the preview, whenever you guys do the, what do you call it again? The practice for the test. Okay, so let me go share StatQuench. Share that. How do I do that? The first thing I'm going to be doing is the following thing. I'm going to go to start right here. Okay. Then I'm going to go to proportions because we're working on proportions. Where's proportion? Right here, proportions. And I'm going to say one sample. Okay. You're going to say, let's see the one with summary because I want all everything together. Okay. So right here. Now, in my problem, I say that 176 of 200 patients was only selected to receive treatment survive. 176 people survive. So my success will be 176. Number of observations. So we observe 200 people. And then 176 say they survive. Okay. So don't touch anything there. And then you're gonna say the confidence. You're gonna click on that one right here and then put the confidence level. Your confidence level is 0.90 in this example. 0.90. Okay. All right. That's all you have to do. And say and press compute. Let's see if does our answer match. So this is what happened. As you can see here, the standard say it's going to be 0.842. This is you put LR for lower limit, 0.842, and the upper limit is 0.9177. Okay. So the simple proportion was 0.88. The total people you survey was 200, and then 176 say they survived. The standard error is given to you as well. It's going to be 0.0229 something, okay? So here you got the interval. So if I want to add the interval, I can say my interval will be 0.84 to comma 0.918, just like we had it before. And my p hat is 0.88. My standard error is 0.023, etc. Okay? Any question about that? And then put my mic. Any question about that? Okay, so you guys see how to do it if you want to use the start crunch. Okay. That then I can say because I was using earlier 0.90, I can say I'm 95%, 90% confident that etc. Okay, that 84% and 91%, 91.8% people survive, etc. Or I can say the proportion P belong to that interval. That's one way. Okay, I'm gonna stop sharing that and go back to my notes. Okay. Which one I'm sharing? Let me just stop sharing for a minute. I'm sharing PowerPoint presentation. Okay, so yeah. So we're able to find the same answer using start crunch. Okay. So again, I just talked about that. That's an example, and I didn't know they use. I don't have to go. You just have to read this one. Okay, I just talked about it many times. Okay. No, hold on. So at least we did anyway. I don't want to skip that part. It's very important that because we're gonna need in the future. John said 200 voters. They said they were asked if they favored the bond initiative to fund a new college sport arena. 120 supported. The number confidence interval is this number right here. Okay. So we 1 out of 120 out of 200. Okay. This one says Senate initiative require over 50% of the voters to pass. Okay. For you to pass it, they want over 50%. As you can see, this number is way below 50%. Okay. It's way below 50% because the highest one is 46%. Okay. So of the voter to pass and the 0.5 is above the confidence interval, it is unlikely that the bond initiative will pass. Okay, that's a good idea. So read that one again. So because here they wanted 350% to be, they wanted 50% to pass the bill, but because your interval is below 50%, it's not gonna be passed. Okay, so that's an interpretation of it. So take your time to read this one carefully in the exam, because you need the interpretation sometimes to have people outside. So again, just like we did earlier, we did to show how to use StatCrunch earlier. And then you put the numbers, you put the interval that you want, and you calculate. That's the steps that I'll show you earlier, and etc. And this will give you the lower limit and the upper limit. Okay, so this is if you have to use StatCrunch, and then confidence interval summary, etc. right here. whenever this one right here is for you to just we already talk about this one. We already talk about this one. This is the most common one, but this one said to use a lower thing. This doesn't really belong to you, but this is just in case they ask you in the exam. A lower level can be used if you need a smaller margin of error. And a high level, this is something, but you don't decide for this, okay? When I give the exam, I decide the level for you. You don't decide it, okay? If you decide it, then there'll be like too much stuff going on. I decided for you, but it's good to know that if I want a lower level of 90% can be used if you need a smaller margin of error, okay? And if you cannot say 95% if you need larger or margin of error. So it's good to know these things, but you guys don't do those things. I give it to you on the exam, something like that. All right. So there are examples that you can also go practice on this by yourself. So I'm gonna stop here. I'll let you work on this one on your own. Okay, do practice this one. Okay, on your by yourself. Okay, this is the example I'm talking about. So this one, which is one part of it, we use that's an example. Say that this thing right here. I'm just show you we did that part already. We did the curve part. Oopsie. Okay. So go practice them. So I already work with you. Somebody already told me that they were confident using the normal curve. So there were no problem. I'm gonna skip this one. So go work on them. All right. And then I'm gonna upload this note for you tonight. And then if you have any question, please stay. I can help you out if you intend with me. And if not, enjoy the rest of the evening. Okay.